We studied a particular kind of screening device that would sit at the end of the offshore intake line. And it would be passive, there's no moving parts. And in fact, it'd be made out of a screen material that's very, very fine, narrow slot. I'm holding up a piece just to illustrate. These are the openings. They're 2 millimeters wide. And so anything bigger than that is not going to go through this screen. So our question was, operating this kind of a screen in the open ocean, and we did it beneath the Santa Cruz wharf, what would happen to its interaction with the ocean waves and currents, as well as the larvae that are in that water column that would be screened out or not. And we also had to look at whether or not we could put metal out there that wouldn't become so fouled that it really wouldn't operate with organisms or have other corrosion problems. Here's a picture on the right here of our model that we hung under the pier or the wharf. I'm going to show you some video right now. First I want to show you, we studied the interaction with dye. This is a completely non-toxic, just like food coloring dye. And here's the screen underwater, beneath the water. The screen is pumping water through a pump up above. It's operating at 0.33 feet per second through the velocity through the slots. And what we learned immediately was when we see the interaction of wave action and this screen, that there's an enormous amount of accessory velocity and currents created by the interaction of the screen and the wave patterns. This was surprising to us. Most of these screens have been used in rivers where they have laminar flow, uniform flow, and in the open ocean, and you can see a piece of algae that hit the screen, it just kind of rolls right off. So we're not even getting plugging out there in the presence of these waves that are acting to create currents around the screen. This is the same setup underwater. We're filming at night with lights, and we're going to watch the interaction with the screen. This is a time of the year we had billions of larval rockfish out. This is their season. That's what's swimming right in front of this screen. And you can see that their interaction with the screen very closely mimics the pattern of dye in the interaction with the screen. And we're watching to see if anything is actually sticking on the screen. That's the impingement side of it. And this was an attempt to study impingement on a fine screen like this. We've studied hours and hours and hours since we had almost zero impingement. And it's because the wave actions act to pull and warn, if you will, and give clues to the fish to make motions in the other direction. And we can very confidently say there's zero impingement with this kind of a screen.